listening to the Futures Podcast with me, Luke Robert Mason. On this episode, I speak to the pioneering professor of cybernetics, Kevin Warwick.
We plugged my nervous system live onto the internet and linked to a robot hand back in Reading in England. So my brain signals in New York were controlling a robot hand in Reading in real time, and I could also feel what the hand felt.
Kevin shared his thoughts on augmenting human capabilities, the exciting field of robotics, and what it means to be a cyborg. This episode was recorded on location at Coventry University in the United Kingdom, where Kevin is the Deputy Vice-Chancellor of Research. So, Professor Kevin Warwick, you are the world's first cyborg. What does that mean?
Yeah, well, I like to think so, Luke. Well, to me, a cyborg is a bit like the science fiction definition. So you take a human, you implant some technology into them or with them in a pretty permanent way and give them extra abilities. So I know there's some people think cyborgs might be somebody who can ride a bicycle is a cyborg because they have some technology. I mean, that's not really what we're talking about with cyborgs. And also, if you're wearing glasses, well, you take them off and it doesn't change mentally what you think you can do. So, and it's not just repairing prosthetics to replace a leg. I think it's when you get extra abilities and you have technology that's implanted in you. And I've been there, and hence I don't oppose such a definition of myself. Yeah.
So what were some of those projects that got you that title of the world's first cyborg? I know the first one was BrainGate, was that right?
Well, no, the first one was actually an RFID. That was, that was back in '98 when I was just a wee tot, as it were. But I mean, you have to think at the time, nobody had an implant of anything like that. People had cochlear implants and so on, but I had an RFID. It was radio frequency identification device, which identified me to the computer in my building. So as I walked around, lights came on and doors opened, all sorts of fun things like that. And then 4 years later, yes, I had a BrainGate implanted. It was the first BrainGate to be implanted in a human, and it was in my peripheral nervous system. I'm waving my left arm around here. I think you can still see some scars from the operation. And it was implanted in my nervous system to link my nervous system with the computer. And it was in there for just over 3 months for the experiment. And we did all sorts of fun projects. So some of them, let's say I moved my hand and we sent those neural signals that did that, which we could pick up monitoring the signals from the implant and send them out to a robot arm. So my brain signals were moving my arm, as they do, but also moving a robot arm. And I did that as an extra, always trying to push the boundaries. I went to New York, to Columbia University. We plugged my nervous system live onto the internet and linked to a robot hand back in Reading in England. So my brain signals in New York were controlling a robot hand in Reading in real time. And I could also feel what the hand felt, because the robot hand had sensors in the fingertips, and we could send back signals to it. So I got a feeling this was in terms of electrical pulses that my brain could understand. And as the pulses increased, so the hand was gripping an object more. And so I had that from UK, had this extra sense of feeling, if you like, from the UK back to the US.
So what are some of the responses that you get when people hear about these sorts of interventions into your own body?
Well, I mean, people are still interested. You're talking to me now, so people are still interested to find out what did it feel like. Some people want to know. Of course, you get that audience which, grumble. I'm not sure why. Maybe because they didn't do it themselves. And of course, in the medical world, the same implant now has been used a number of times for paralyzed individuals to do exactly what I just been talking about, only in this case they can't move their hand, so it's giving them the opportunity either to move a robot arm from just thinking about it effectively, or in one case now recently they've put a sleeve around the wrist of a paralyzed individual, and when he thinks about moving, which he can't do himself, the signals from his brain are used to stimulate the muscles in his arm, so it actually brings back some movement for him. I think ultimately they'll connect not to a sleeve round his arm, but into the nerves. So it will be effectively short-circuiting the break in his nervous system that causes his paralysis.
So in those cases, it's, for want of a better word, it's disabled individuals who get access to this technology first. I mean, to a degree, you're arguing that able-bodied individuals should be able to use this technology to create new experiences.
Oh, very much so. I mean, the therapeutic side of things, the system, the world system, the medical world and so on, is set up to cater for that, to experiment to some extent. And hence, when I had the BrainGate first and experimented both in terms of therapy and in terms of enhancement, and the therapeutic side of things, they're now probably about 5 or 6 people that have also experienced it for therapy because they're paralyzed. But the enhancement thing, I mean, I was expecting you, Luke, to have a go yourself with it, because that to me is the really exciting area. As humans, we're pretty limited in what we can do, let's face it, mentally particularly. We just have a bunch of brain cells, and the possibility of enhancing our brain, our mental capabilities, I think is enormous. And what we could be able to do with implants like BrainGate, I think is incredible, but we're not doing it yet. So that for me is really where the real excitement exists, in the enhancement side through implants.
Well, even in the last couple of months, as folks like suddenly Elon Musk and the entrepreneur Brian Johnson have entered the market. Elon with Neuralink and Brian Johnson with the kernel both want to create a neural prosthetic.
Yes.
Yes. And to a degree, that's a response to the fear of artificial intelligence. They see neuroprosthetics as a way of upgrading humanity to deal with the coming AI apocalypse in some cases. Do you agree that these projects
100%. But I mean, in 1997, we're really going back into the last millennium now, I published a book called March of the Machines, which was looking at the potential AI apocalypse. Saying, well, in something like 50 years' time, so 2050, it was putting a scenario in 2050 of an AI apocalypse, because humans are creating machines with a sort of intelligence that we don't particularly understand, particularly with a networked intelligence, which we don't really have ourselves, and deferring to it more and more. So I definitely saw the dangers and can see them now. And it's great that Elon and others are coming on board and also seeing the dangers. So the different people coming from different angles can see the threat, and hence, as humans, what are we going to do about it? Just take it on the chin? Well, then what? We become second-class citizens? You know, we've got machines running the show, Terminator style. What's going to happen to humans? The best we can hope for is that we're kept as pets, or, you know, in a zoo or something like that. Well, frankly, I don't fancy that myself. So the only alternative is really to encapsulate that AI yourself. If you can't beat them, join them. So to upgrade yourself. And it's good that Elon and others are now suggesting the same sort of approach. And that's really with the implant that I had, it was a step in that direction to see, could we upgrade humans? Can we enhance humans to some extent? If so, what does it mean?
But the general public has this very visceral response to any sort of technology that's placed under the skin. Do you think these devices will continually be silicon, or do you think there'll be more of a biological enhancement?
I think it could be both. I mean, silicon There's lots of materials. Materials are not a problem. I've got some platinum wires that are still in my arm. They've been there since 2002. They don't do anything. They pop up occasionally. I'll push them back in, but they're not actually doing it. The body doesn't bother about platinum, titanium. I've now got, see, a gap in my tooth there. I'm having a tooth implant. There's a big titanium screw in my bone. The body doesn't bother about it at all.
I would have loved to have been a fly on the wall for the interaction with your dentist when he said you had to have a tooth implant. You were like, oh, no, that's nothing. I've had worse elsewhere.
Yeah, just get on with it. Well, it was exactly that. But the point is, there's lots of materials the body doesn't bother about at all. But that's, looking at one way of doing it. And there's lots of other ways of doing it, like growing entities. We grow brains for robots in a little dish. And I mean, it's a different approach to the whole possibility. So a mixture, some technological, some biological. And I think there are all sorts of different mixtures of what could be possible.
So how did this interest in artificial intelligence, robotics, cyborgs, where did that first come about?
Oh, I think as a kid, I was very much into technology. I mean, then it was things like motorcycles and so on. But at the same time, science fiction. I thoroughly enjoyed as a kid War of the Worlds. Really disappointed at the ending. I think H.G. Wells could have done better. Humans win. I think, oh, come on. But apart from that, and Michael Crichton, I think, always inspired me. He wrote a book called Terminal Man. And that I thought was brilliant. I saw it more of a scientific book, which again was sort of how Crichton is. It's sort of pseudoscience, as it were. But the whole possibility of somebody having an implant in his brain, which is what Crichton was talking about way back now, and then how that affects his brain, Crichton really looked at. But for me, it was inspiration. My father had agoraphobia, and they operated on him at the time. As he described it, they drilled a couple of holes in the top of his head and cut out some of his brain cells in order to get rid of his agoraphobia. It's not something they do now because of the dangers associated with it. But for him, it got rid of his agoraphobia. I mean, he was an extreme case. But to see the transition for him of just changing a few brain cells, that's all that happened, and yet it completely cured his agoraphobia, was brilliant, which overturns a lot of there are some philosophers that, you can take out a few brain cells, it doesn't make any difference to the brain. That's a load of codswallop, which is typical some philosophers. You can take out a few brain cells, it makes a dramatic difference to the person. I saw it with my father, exactly what happened. Sometimes it may not make a difference, but sometimes it can make a dramatic difference. And the possibility, therefore, of putting signals into somebody's brain that completely changes their personality in some way, I think it is a fantastic opportunity, both for therapy, but also to change the person, potentially to enhance them.
You may be able to enhance the human, but also they'll be changed fundamentally and differently. You talk about changing someone's fundamental sense of self with these tools, people get very viscerally negative towards that idea. There's a feeling that technology is a control mechanism rather than something that you work together with. I mean, what's your response to people who have that
But I
view?
think there are people who, I don't know, how can I describe it? Even with intelligent machines, it's never going to happen. We'll always be in control of them. And other people, that's great that you're saying that. Have a knighthood or whatever, whoever you are. I won't mention Roger Penrose or anything like that. No logical argument, but say, there'll never be a problem. People want to hear it, so we don't have to worry about it. But it's rubbish. Philosophically, there is a potential danger from intelligent machines. We have to face it. And when it comes to integrating the body with technology, it is going to affect how the brain is. You take on extra abilities, you may lose some, you may well, I would think, in terms of how ethically you consider yourself and other people within the world, dramatically change your beliefs. I mean, let's say, Luke, you're just a regular human at the moment, roughly
All right,
speaking.
okay, I'll be a regular human.
A regular human. And let's say here I am, and I upgrade myself from being a regular human. I have implants that allowed me to communicate with others just by thinking about it. And then I have some others who also have implants, and we can communicate by thought. Now, you're just a regular human. You have no idea what we're communicating. You're coming out with these silly human noises called speech, these mechanical pressure waves. Meanwhile, we're on a whole different plane just in terms of communication. So you say, hold on a minute, I don't like you doing... What are we going to think about you making these silly noises? You know, I mean, are we going to say, yeah, we'll pay attention to what this idiot's saying on he can't communicate like we do. I mean, Nietzsche had philosophy that looked at this. I mean, how people who have upgrading implants that allow them to do not just to communicate by thought, but to control technology wherever in the world from their brain, etc., 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 have new sensory input, can understand the world in more dimensions, blah, 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 blah. How you're going to regard a regular human? Probably not very well. But if I look myself, I would say, well, I have the right to upgrade as an individual, to upgrade if I want an implant like this, to have some of those abilities. And humans, from when humans appeared, have gone in to improve ourselves. We started to fly, we drive cars, we have also technology. So humans will go for it. Humans will go for the upgrade. That's what will happen. And some people will get left behind.
But do you think the thing that will really stop the ability for humanity to upgrade in these sorts of ways are the nation state? Do you think there will be some sort of top-down governmental control saying we shouldn't be doing this to the body or we shouldn't be doing this to ourselves?
I'm sure there will be some people that try and put that down, but it happens. It happens. But I know, not sure now how much the nation state is that important in terms of how it was, particularly with computing, with the internet. It's more of a global state now, and I can't see why we don't have a global time, for example. Why do we still have these stupid times around the world? We progressed from having times in one town and another town, so we have regions. Now with computers, I think we should have just one global time. We all work on the same time, and it's the same in terms of ethics and things like this. I think that we need to move to the next step now, instead of having the trivial little arguments between nation states and things like that. Let's get on with the new world and progress in ways that we can push the boundaries. But I think with technology and what we're looking at in terms of enhancement and upgrading, that could be the leap forward. That could be the step forward. Whether you can regard it as an evolutionary step, of course, is down to your genetic argument. And do you believe in this way or that? But I think it could give us that major push forward in a non-linear way. And those that do upgrade will not be bothered at all by silly ideas of nation states.
Well, does the end goal need to be enhancement necessarily? Does it need to be an upgrade? So the new generation of cyborgs, such as Neil Harbisson, he doesn't see his ability to hear colour. He's the cyborg artist with an antenna that allows him to hear colour.
Fantastic. And it's interesting with him, the way his new ability, because he was colourblind originally, but his new ability now gives him an incredible discrimination for different colours, which, is much better than my normal thing. He has a better ability because of how the information is being brought in a different way.
Well, he doesn't see it so much as an upgrade, but as a different sensory modality. He sees it as another organ, another part of his body.
Yep.
But there's that tricky space because he was colorblind before he had this device. Then, to a degree, it could be argued that it's an enhancement on his pre-existing body. But in another sort of way, anybody can have this antenna, and it will just change the way they see the world. It won't necessarily upgrade the way they see the world.
But it's just making that step. I mean, in his case, it was sort of a replacement, but now it's giving him an ability beyond what humans have. For the experiment that I did, I didn't have a medical problem. So when I was able to control a robot hand across the internet and so on from my brain, it was directly an extra ability. And you have to make that step forward yourself, which I think people will generally do if they regard it as being relatively safe, and if they think it's going to give them lots of other abilities. I mean, I'll take an example with this, laser eye surgery. If I said about 20 years ago, I'm going to give you laser eye surgery, you'd just, are you crazy? You're going to blast lasers into my eyes? It's highly dangerous. No way do I want anything like that. That would have been the response, when it's perfectly normal. Now, somebody has poor eyesight in one way or another, they want laser eye surgery because it's deemed to be safe, it works all the time, there's no negative after effect, and it dramatically improves your eyesight. So as long as implant technology and the sort of thing we're talking about is deemed to be reasonably safe, and it gives you certain abilities that you wouldn't have otherwise, such as the ability to communicate just by thinking to each other, I think people will go for it. It's getting over that step.
When it seems, especially the RFID tag technology, it seems to be now in certain parts of Europe, you can only enter your office if you get a chip. There's whole organizations who are telling their employees that they must be chipped. And I think that's at least a good example of one of the pieces of embedded and implanted technology that has become socially acceptable, partly because we realize that it doesn't have any negative long-term effects. That you can go into MRI machines and you can go through airport scanners, and these things don't fly and rip out of your body, and
thousands of people have got RFIDs implanted now, and I think it will be used more and more. I was at a health conference yesterday, and it was talking there about the use of RFID chips, partly to identify patients, to make sure, for security, to make sure they've got the right person, but also if somebody is having an operation on a limb, to put an RFID chip in the limb that's going to be operated on to make sure that they get the right limb, because you get mistakes cropping up. So examples there, where it will provide a degree of safety. And if you say to somebody, okay, now I'm going to implant this small little thing, it's the size of a grain of rice, but it's to make sure that we operate on the right leg, the appropriate leg, then the person, okay, sure, I'll go for it. I'm happy to take that to make sure you do. So it's when the person sees the benefits that are there, and they deem it to be pretty safe. And that's one prime example. We're going to see that awful lot more.
Do you think we'll all be chipped from birth?
I can't see why not. Yeah, I can't. Why would need to? I don't. But I can't see why not. It depends what chips are going to be put in. Just an RFID as a passport type of thing has benefits, and you might need to upgrade your implant from time to time. But I think it provides a wide variety. I'd like an implant that gives me an X-ray sense, for example, but it would be good to have it at birth. So as the person develops at birth, they develop with that new sense as though it's always been there.
So why an X-ray sense?
Well, I mean, I've had an ultrasonic sense, which is cool. You haven't experienced it. It gives you ultrasonics gives you a fantastic sense of distance, very accurate. If something moves slightly towards you or away from you, you can detect it. Play a lot in robotics with infrared, which is a remote sense of heat, which is great. The brain can take on board that. You can tell how hot somebody is, for what it's worth, from a distance, things like that. But X-ray, I mean, it could be useful in the medical world, obviously, but I think it's just something a bit different. And I'd like to know, would my brain take it on board as we sort of take it visually now? We convert X-rays into visual pictures so humans can understand them. But what would it be like to take on board those signals basically? I'd just like to find out as a scientist. I'd love to have it. Infrared and ultrasonics is a little bit boring. Let's go for X-rays.
Now, all of your work is done safely in a lab-based environment, in a university-based environment, or in a research environment.
So, use of that word "safely" was an interesting one.
Well, my question is your thoughts on the grinder movement, the individuals who are taking a pro-actionary approach to their own body. They're taking scalpels and a bottle of vodka, and they're just implanting things by themselves to just find out what works, what doesn't work, and they're finding some complications through this self-experimentation. Do we think we're going to see more of that, or do you think that's just a very dangerous thing for people to do, and we should wait for individuals like yourself to take the first steps to be able to tell you what is biosafe and what do you want to avoid at all costs?
Luke, I think when you're doing it for the first time, no matter what paperwork you fill in, there are still enormous dangers there. I mean, maybe I was a little bit different, that I've always worked with doctors and surgeons, so the neural implant that I had neurosurgeons involved. But for them, this was the first time it had happened in a human. And to be honest, the surgeon took me to one side about 3 days before the implant went in and said, look, if this goes wrong, you're going to lose the use of your hand. So do you still want to do it? And it was good that he did, because I could say, of course I want to do it. We've sort of got ready for this for if it goes wrong, it goes wrong. That's the risk you take. I mean, in a way, I had a good idea of what the risks were, because there were medical people there. The risks were potentially reduced in terms of infection and other issues. But I think some of the grinders there are doing a fantastic job. I mean, it depends. This is not saying go and do whatever, so I'm not giving a sort of carte blanche for, Kevin said I could do. But I think from a scientific point of view, I keep a close eye on what they're doing. The guys in Pittsburgh, for example, Tim Cannon and the others there, doing a fantastic job. And the way they report things, more in their own way, it's not in a sort of the straightforward academic, scientific way as would be normal from a university environment, but they do report on the materials that are used. We've got these results. So they report in a sort of a scientific way, which is very useful for me and the researchers I work with in terms of what reactions have occurred, what the long-term, the durability. Sometimes what they put the implant in, they have to take it out again pretty quickly because there's an issue. And those sort of things we learn from. They report on the issues, good or bad, and I think that's vitally important for what they're doing. So, I think it's great that there are such people. We benefit from it, and I think the academic world and scientists and the medical world benefit from what they're doing in a different sort of way. Long-term, people will benefit. So the numbers are increasing, and why not?
No, I definitely agree. Emil from Dangerous Things, who implants the chips in people's body, I saw a presentation from him recently, and the fact that he was so open about the things that could go wrong, about the things that you should be aware of before you sort of make these decisions.
Oh, yes.
I think it was great that they don't always just evangelize the idea of technology in the body. They are very honest about the possible challenges of even things like RFID tags may travel around the body. If you have certain muscle tone, then you really don't want to chip in certain parts of your body, or if your lifestyle is a certain way. They are good at communicating those concerns.
Yes, and I think now, of course, with things like RFID, it's specially sealed. It's designed for implant in the body. The thing that I should have brought one with me now, was about 1 inch long, 2.5 centimeters long. It was in silicon in glass. It was a glass silicon. I say silicon, but it sounds silly, but it was a glass tube. And we thought, it's got to be sterilized. This was with the GP doing it. We're going to have to sterilize it. So we tried in the lab to sterilize the thing by boiling it in water, and it exploded. And there were bits of chip and electronics all over the place. And we thought, blimey, if this goes in my arm and does something like that. So it was actually put in an oven to heat up to about 80 degrees instead of 100 degrees, and that was how it was sterilized for my implant. But we always knew that because it was designed more for computers, it wasn't designed for the human body. If someone had come along and said, "Hey, Kevin, how you doing?" and patted me on the arm, I could have had bits of electronics just floating all around, as Amel says. It can move around your body and everything. I could have bits of chip all over. It would have been very difficult to get back out again. You take risks like that before the technology is improved, and you're not fully aware of what the risks are, and whatever forms you fill in for university or company, nobody can actually know, because you've not actually done that. Nobody's done that with that piece of technology before, so you don't really know what the risks are.
I mean, how do you advise, say, your PhD students who come to you and sort of go, "Look, I've got this idea for putting this here." What sort of advice do you give people to make sure that they are aware of potential dangers or challenges or concerns of some of these things?
Well, it is from historical grounds, so it depends what the implant is. I had 3 students now who've had magnets implanted in the fingers. So it's doing some work initially on the type of magnet, because now the encapsulation for the magnet and the material that's used is pretty well versed, but we need to do the homework on that. So make sure you get the right sort of implant that is well tried and tested first of all. And so it goes on. And when you're connecting up, putting wires around your finger in order to stimulate the magnet and so on, that has been done before. So they read up on it, make sure we know the best we can do before going ahead. Here's me talking about it, because it's just about the opposite of what I did myself, but there we go.
I mean, did you get any advice from the university institution at Reading? Did they sort of go, "Oh no," or did you just keep very, very quiet?
No. I did go through all the appropriate channels, but I think with the BrainGate implant, of course, it was a world first, so no human. The only thing, reports that we had of the Utah array, which is the sensory part of the BrainGate, had been used in chicken sciatic nerves. That was the only academic papers that have been reported. So that was what we had to go on, surgeons as well, before it was fired into my nervous system. So for the surgeons, it was very much a research project. It wasn't I could trust them because they knew what they were doing. They didn't know what they were doing at all. They were firing the thing in. They were buying lumps of meat from Sainsbury's in North Oxford and trying to fire these things into just to practice. And again, just before the operation to put the thing in my nervous system, the surgeon said to me, "Well, the good news is we're pretty good at actually firing the things into we think the nervous system now, lumps of meat, but the problem is we can't get them back out again." So, and the whole plan was that this would be taken out after a few months. So again, do you want us to go ahead? Yeah, of course I want you to go ahead. Fortunately, whilst the implant was in, they were able to work out how to get them out again without breaking off, because this array has 100 spikes on it, which are very, very brittle, and you have to try and lever it out again, which they were typically breaking about 50 of these spikes off to get the thing out again. So, and I didn't fancy having all these spikes from the array left in my nervous system. So they were fortunate in part of it.
Is there anything on the coming horizon that you're looking at going, "That's the next thing I want in my body, in my modalities"?
There's just one thing. It has to be the brain implant. So it's pretty serious, because putting anything into the brain, you have the dangers of bleeding. There's a small percentage, and it is, I believe, very, very strongly that we will be able to communicate by sending signals from brain to brain. I find it such an exciting possibility to research, because we don't know what that means. You're talking about changing the way the brain is, the possibility to communicate in a whole new way, because brain cells like to communicate. That's what brain cells do. When people say, "Why do kids, get on Twitter? Why do they have Facebook?" Well, they've got brain cells. Brain cells like to do that, of course. So, and therefore, what my brain cells will do when they can start to communicate just directly, not through this old-fashioned thing called speech, but directly, I don't know. And hence, even from a philosophical point of view, it's tremendously exciting. Do we actually think in some strange, structured, linguistic type of way? I don't know that we do, or do we think in a communicative sort of way, which is more how I would take things. So it will overturn a lot of the philosophy that we've been basing things on for a few hundred years now. So I'd love to do that, but it's serious stuff. And still, just where we are now, the surgeon Amjad Shad, who put the brain gate into my nervous system, still very much talking to him just a few days ago about the next step.
Thank you to Professor Kevin Warwick for sharing his unique vision for the future of humanity. If you like what you've heard, then you can subscribe for our latest episode, or follow us on Twitter, Facebook, or Instagram @FuturesPodcast. More episodes, transcripts, and show notes can be found at futurespodcast.net. Thank you for listening to the Futures Podcast.